Okay, so as informed earlier, that today onwards I will discuss decision making and branching, iteration, these two very important constructs in more detail. Although Joydeep sir has introduced some of the features, as you have mentioned that this typically in a C program, compiler executes statements one by one sequentially, but only mere sequential execution may not help us to solve all possible problems. In many uh, solution targeting solving problems, we may have to do something different based on certain condition at different runs for different inputs. Same program, there should be some of the statements whose execution will be conditional with some respect. Like there may be 1,000 lines of codes in a program. Now the same program when run with different inputs, not all 1,000 lines will be executed in the given sequence. There should be some set of statements whose execution will be conditional. Like based on certain condition, if that condition turns out to be true, then certain section of the code will be executed. Otherwise, they may be skipped. And some statements will be there that they are going to be executed in every run, like these all the statements before this condition and all the statements outside of this conditional block. Okay, and there may be different variants of this conditional check and this branching, and this is the most typical uh, branching, that there is a set of statements whose whose execution is conditional based on this satisfaction of this condition. Now we can have several other variants like as complex as this or uh, other like that. So in this particular course, the coming few lectures, we will try to understand that what are the different variants of such branching based on decision, and what are the tools C language offers us to take help and implement such required branching. Okay. Now, as I have mentioned, the most important thing is the condition. In any kind of branching, conditional branching, we need to understand what do we mean by condition. So first, I'll spend some time to let you understand in what way we can represent conditions and what are the interpretation of different types of conditions and how they helps us in branching. Okay, so basically condition represents a logical expression or a relational expression that can be evaluated as true or false. As you can see in this diagrammatically representation, which formally which is known as flowchart, that this is a condition. The result of this condition can either be true or false. So if it is true, then this set of statements will be executed. If this is false, then this will be skipped and directly this statement will come. Okay. So this condition must be to some extent evaluated as true or false. Okay. But it may not always represent a logical expression like using logical and logical or and relational expression greater than equal to less than, not like that. Typically it will look like this, but in some cases it may represent other type of expression such as arithmetic expression. Now how this true or false gets interpreted? In case of an arithmetic expression, any non-zero value, positive or negative, all the expression has a result. The result will be interpreted like, if the result is having any non-zero value, both positive or negative, that expression is accepted as true. When the result of the arithmetic expression is 0, then only it is interpreted as false. Okay, I'll show you an example code with several different types of conditions. Okay, and how they are interpreted. but let us see some of them in the slide for
Sir,
further. Hmm.
one thing, sir, that true in that bracket one means that the integer value for true is one, right?
Yes, so true, as I have said, I mean, if you have an arithmetic expression, huh, that is interpreted as one. I mean, any non-zero value. Huh, true is one or false is zero. Okay. It is not only one, actually, it is any positive or negative non-zero value, I should rather say. Okay.
Okay.
So ultimately, logically, you should expect that whether it is true or false, condition wise. Okay. But since we are not limiting ourselves only with relational expression, which explicitly returns a true or false value, we are allowing logical expression, arithmetic expression, then that's why this true and false needs to be interpreted some indirect means also. We'll see some example. Let's see. So this is the most trivial way, this relational expression. That suppose instead of for simplicity, I have written this type of statement that x is initialized as 5, but instead of that, I could have written int x, and then I could have a scanf expression which will take the value of x. So apart from this, if I write like these two statements, if replace. Now see, same program at different run will get different values for x. In some run I may enter 5, in some run I may enter -3, in some run I may enter 0. Okay. The same program, I am not going to change the body of the program. I have compiled the program once and I am running it for several different times. And since my program includes a scanf statement, every time it runs, it will expect a value for this x from the user. Now, depending on the value user enters, this condition will be sometimes satisfied or sometimes dissatisfied. Suppose when user enters exactly 5, then this condition will be true. So this statement will get executed in that run. Okay. Now, if sometime user enters -3, then also, I mean, not -3, x -3 is not equal to 5. So this will be false. And so this statement will be skipped. So this is how the execution of this particular statement, or if there were more statement within this block, the fate were same. I mean, all the statements that are put inside this block under this if block, their execution will be conditional to the satisfaction of this particular condition. Whenever it gets satisfied, these statements will get executed. Otherwise, they will be just skipped, and all the statements after that block will be executed without any dependency on this condition. But thing is that when the value of x is exactly equal to 5, then only this condition will become true. So this is the meaning. So this is the most uh, typical way of representing a condition using a logical expression: equal to, greater than equal to, less than equal to, like that. Okay. So this will be obviously evaluated as a true. Now next one, what will be the result of this condition check? Whether it will be interpreted as true or false. Here, see, I have hard coded the value. I have given the value of x as 5.
True,
Then
sir, true.
true, obviously, because 5 is greater than equal to 5. It is true. So it will be returned as true. Next, x less than 5. Obviously, this is not true. So because x is assigned a value 5, 5 is not less than 5. So this will return as false. Fine. So this is how the logical expression will help us interpreting condition. Now, it may have a complex expression, like it is a relational expression with some arithmetic components also. So value of x is 5, value of y is 3. So 5 minus 3 plus 2 Is it greater than 5?
No, sir, false.
Because
No,
the
sir.
left hand side of this greater than is 4, evaluated as 4. And you remember, you have to apply the operator precedence and associativity rule here. Huh? So it will be interpreted as false. Now what about this? Considering value of x to be 0, value of y to be 2, value of z to be 3, what will be the result of this condition? Understood? What will be the result? X is
Sir, I
0.
think it will be true because the binary equivalent will be 3 of this expression.
See, first you have to fix these two, logical and logical or, they belong to the same precedence level. And if you check, they have left to right associativity. So this logical and will be executed first. So x value is 0, y value is 2, non-zero. Now logical and returns 0 here.
0.
Then 0 or z, which is non-zero. So it will be non-zero. Final result will be non-zero. 0 or 3, which is a non-zero value, obviously. Because or, a non-zero on the one hand side indicates that result will be non-zero. So it will be interpreted as true. Understood? So try to check this one. This is not a simple relational expression. It is a logical expression. How it is interpreted as true or false. This is very important. Okay. Now what about this? Here what I have done, I have modified the expression a little bit just by including this parenthesis. That is how I am overriding the
False.
default precedence or associativity. Here, since I am including this parenthesis, it is having highest precedence. So this or will now execute fast. So or 2 or 3, it will return a non-zero value. And then this 0 with a non-zero value will be logically ANDed, which will return a 0. So result of this entire expression will be
False.
0. 0, which will be interpreted as false. Everybody understood that? How this becomes false, not true? Just a
Yes.
little bit change.
Yes, sir.
Here, there were no parentheses. Here, I have just included a parenthesis here to override the usual precedence level. And the result becomes different. That you have to remember, that how these conditions are evaluated. Just like you have to evaluate expression following the precedence and associativity, and then check whether it is returning true or false based on whether it is a non-zero value or zero value. If it is not a relational expression, a relational expression will always return directly true or false. But other type of expression, mixed expression, may return some value, some result, which is not directly true or false, but it should be interpreted indirectly, whether it is true or false based on the common rule. Okay. Now, an expression, a condition may be as simple as this, like there is no operator, only variable or constant. What will be how it will be interpreted? Is it true or false?
True, sir.
True.
Non-zero value.
Huh? True or false?
True.
So
True.
true.
Because see, although it is x, only x, a variable, it can be thought of as a simple expression, the simplest possible expression, whose value is 5, a non-zero. So it should be treated as true. Okay. So this type of thing will be accepted as true. Now, when the value of x is minus 5, so as already mentioned, that
It's
non-zero
also
value, even it is negative, will be accepted as true. So this will also return true. Understood?
yes, sir.
Now, instead of an integer, if I define it as float, what will happen?
It will remain as true.
Hmm?
True, sir.
True only.
True. Following this rule, any value which is non-zero, positive, negative, it may not be always integer. Even if it is float, it will be accepted as true. Okay. Now, only when the
False.
value of x is assigned to be 0, then it will be treated as false. So here, this condition will be evaluated as false. Following the same policy. Be it int or float, doesn't matter. Since it is 0, it will be accepted as false. See, this is minus x, x equal to 5. As usual, true, because minus x means the result of this
Non-zero.
expression is minus 5, which is non-zero. So it will be accepted as true, no problem. Now, this type of expression, see, it's an assignment expression. It is not a relational expression, mind it. I am using single equal to, not double equal to. How do you expect?
Sir, it will give an error, I think.
Hmm?
Error it will give because assignment operation cannot be used in place of logical operations.
No, I have not said. See, you read the rule. Read the rule, how condition gets evaluated. It belongs to any other type of expression. So it is, I have not said that I have to only use logical expression or relational expression. See, most trivial way of representing a condition is relational expression. But you are not bound to use only relational expression. You can use any kind of expression. That's what we have seen so far. So this is also an expression. It also has a return value. When you return x equal to 7, this statement, the return value of this expression is 7. Because ultimately 7 is getting assigned to the value at the left hand side. Okay, it's a non-zero value. So this will also be interpreted as true. It will not generate an error. Okay, so you can check. We have an example, we'll see. This will return as a true. Now, x equal to minus 7. As usual, the return value will be minus 7, which is again non-zero. This will also be interpreted as true. Okay. But what will happen in this case? X equal to 0?
False.
Yes. Yes. Because the 0 is getting assigned to x and the return value of this expression is also 0. So this will be interpreted as false. Fine. Now what about this string? This type of thing is also allowed. It will also not generate any error. Any non-empty string, if you allow, use as a condition, this will also be accepted as true. Although we rarely use this type of thing, but for sake of completeness, you need to know. that since it is a non-empty string, it has one or more characters, it is also interpreted as a non-zero entity and it is interpreted as true. Okay. Similarly, this statement, printf statement, actually the return value for this printf statement, actually such printf statement returns the number of characters it successfully prints. So actually return value of this printf statement will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so which is a non-zero entity. So this will also be interpreted as true. So this type of thing you should remember. Okay, now before moving into this, let me show you that example program so that you can understand it better. See, I have used this program I have written. So as you see, x equal to 5. This is assignment statement. It will be interpreted as true. So this statement will get printed. If x, since x is already got a non-zero value, this will also be interpreted as non-zero value. If z, where z was assigned a value 0 and was not updated here, so this will be interpreted as false. Okay, so this statement will not be printed. In this way, I have used several different options which I have shown in the slide here. So if I run this, you will see the expected behavior. And you can also use this program to add more such lines to check what is happening. You can think of some possibility and you can add such statement and check. That is the intention of giving this type of program. You can see the result. I will upload, as usual, I will upload this program also. You can download and use it to see the behavior of the program for different such condition, to understand which conditions are interpreted as true, which conditions are interpreted as false, and which generates an error. Okay.
Sir, you told that the printf statement returns the number of characters it is printing. So can we store that value in a variable?
Yes.
Uh,
Yes.
Sir, I wrote one program, but it is not storing that one. That I wrote C equal to printf something, but when I'm printing that variable, it is not printing that. So,
It should print. It should print.
sir,
We'll check it. We'll check it during the lab class. I'll check it.
okay, sir.
Okay. You can also check. Okay. Now, is my slide visible now again?
Yes, sir.
Okay. Coming back to the different variants of this conditional branching. Okay. So we have already been introduced this by this simple if statement. So pictorially, the situation looks like this, that we are coming sequentially. Now we need to express one branch based on a condition where we have to implement this simple branch, that based on a condition, some set of statement will be executed, otherwise they should be skipped. Like this is a pictorial representation you can see, and this is the equivalent example. Like see, these statements are the statement whose execution is not dependent on any condition. They are going to be executed under any circumstances. Whenever I run this program, these three statements will execute. But these two statements, I have encapsulated those two statements inside a if block. If this condition becomes true, then only they will get executed. Otherwise, if this becomes false, they will be skipped and the control will come just after that. And again, execution of these two statements, or if there were more, their execution is totally independent of this condition. So the point to be noted is that the statements that are put inside this block within these curly braces after this if, their execution depends on the satisfaction of this condition. So at different run, these two statements may execute in some run and may not be executed at some run. They may be skipped. So this is the simple if statement. If we need to write programs where we need to implement such things, we'll be using this simple if statement. Like whenever I am giving 0 as a user in some run, if I provide 0 when I have been asked to input divisor, then to avoid any crashing of the program, any illegal operation, I have written this thing. So that time the division will not be done. It will print this error. Okay. So let us take a more real life problem that I ask you to think how you write a C program that takes marks obtained out of 100 and prints whether the student is passed or not. So we know that in 100, if you get greater than equal to 35, you will be declared passed, or less than 35, failed. Now, how should I write a program which will ask the user to enter the marks obtained and then based on that marks, whether it is greater than equal to 35 or not, a printf statement will be there to declare whether he is passed or failed. Let us try. So I have written this program, say int marks obtained. I'm capturing the marks obtained within this variable, and since I am accepting that it will be integer, any value between 1 to 100, okay, or 0 to 100. Now printf enter the marks obtained, scanf, I am getting this value inside this variable, and then I am using the simple if statement. If marks obtained greater than equal to 35, then printf passed. Then I have written printf failed. Is this program okay?
Sir, that
I
failed.
think both will display.
দুটোই দেখা মানে the both one will be displayed.
It should be an else statement.
So forget about else. I'm coming. Why we should we need an else statement. Okay. The thing is that, as they have pointed out rightly, that what it will happen if I give any number less than 35, say if I input a number 30, then the program will output correct result. It will print only failed. Okay, but if I provide any number greater than equal to 35, let's say 37 only, then it will print passed as well as failed, both, which is completely undesirable. A student cannot simultaneously pass and fail, but this program will output like that. When he or she is really failed, then it will correctly print failed only, because in that case this condition becomes false and this statement will be skipped for this input less than 35. But for greater than 35, this condition will be true, so it will print correctly that is passed, but since this execution of this statement is not dependent on any condition, it is going to be printed every time. Okay, so in that way, this program is not correct. Now, let us see if we can rewrite this program to eliminate this problem. Let me try this one. This one. I am using another if statement. Okay.
Sir, it is
Obviously,
fine, but
this will.
less statement can
Huh?
be. It is fine, but less statement can be done. Like we can
Yeah,
use.
so that's what my point. See, those who already know programming, I am not teaching this thing for them. For beginners, I am teaching that this is correct. This will generate correct result. That I have used two condition check. Okay, if it is greater than equal to 35, it will print fast, and then again it will be checked. If it is, instead of just writing a printf failed statement, I have introduced another if statement to check whether that is less than 35. Then only it will be print. So I am making the execution of these two statements, both the printf statement, dependent on some condition check. Since they cannot be printed simultaneously, because I know I am writing a program to declare one student passed or failed, which simultaneously cannot take place. So this is good, this is correct. But as I have already pointed out, it is actually taking unnecessarily test, because what I am doing, when I am saying it is greater than equal to 35, I have already declared in past, so it can never be less than 35. But still I am checking whether it is less than 35 or not. So this is inefficient in the sense it is doing some unnecessary test. Because if you look into this problem carefully, you will find that there is a condition whether your marks obtained is greater than equal to 35 or not. It can have two answers, yes or no. And these two are mutually exclusive. Mutually exclusive outcome of this condition check. When we have two mutually exclusive outcome of a condition check, the better way of representing this using any C construct or any other programming language, the construct is given as if and else. As a common terminology we also use. If this is true, then do this thing, else do this thing. When we do use this thing? When we have two mutually exclusive outcome, as in this case. So this is the better way of representing this if else, and this is how C allows you to implement not only this type of simple mutually exclusive outcomes, but in anywhere, whenever you have two mutually exclusive outcome of a decision, of a conditional check, then instead of using simple if, you can use if else statement. So pictorially it looks like this. This code segment that is put inside if block and code segment that is put inside else block, they are mutually, their execution is mutually exclusive. Either at one run, if this executes, this will be skipped, or in another run, if this gets executed, this will be skipped. Under no circumstances, both of them going to be executed. If you need this type of things to be implemented, then you should use this if else instead of simple if. Understood? So this code inside if and code inside else, they are mutually exclusive. That you have to understand. Is it okay? This is very simple, but very important thing to understand, especially for the beginners. Please respond whether you have understood it, when you have to use simple if, when you have to use if else.
Yes, sir, understood.
Understood.
Okay, very good. This is very important, very easy, but very important. Now, as we have already mentioned, I am skipping this slide, that there is a ternary operator which you can use as an alternate of this simple if-else statement, but it is not recommended. We'll strongly discourage that you use it. You use simple if-else. But if someone uses it and you are given that code to be interpreted, then you should know how this should be interpreted. Okay, ternary operator. So first of this condition will be there, then there will be an interrogative sign, then this is the if part, and then colon, this will be the else part. So if condition becomes true, so this will be the part that will be executed, otherwise this will be the part. So there are three different segments. They are differentiated or segregated by these two delimiter, one interrogated sign and a colon. Okay. Sorry. Now, this if else can be nested also. Like we can have a multi-layer conditional check. In some solution, we need to implement, like if this happens, okay, then there will be an else, fine, but we will not leave it. If this happens, then again we have to check if this also happens. So multi-way conditional check. If this becomes true and also this becomes true, then we will do something. Now if this is true and but this is false, then we'll do something else. Okay, and if this is false and again there is another condition which is true, then we'll do something. And if this is false, this condition becomes false, as well as this becomes false, so we will do something else. So if we have this type of requirement, that it is not only based on only one condition, we will combine two or more conditions, and based on the combination of true false of different conditions, we will have different outcomes. Then we have to use nested if else, more than one if else to be enclosed within one if block or another else block. Okay, so this example nicely illustrates the requirement of such. Already you have seen, I think we have already considered the problem of finding the maximum of three numbers, isn't it? There are several ways of solving this, but let me show this program which uses most intuitive solution, and where we will see that we have to use nested if else. Okay, let me show you that. See, we have taken three numbers. Here we are taking the values of three numbers one by one, and then we are trying to find out which one is the largest. So what we are doing, first we are checking whether n1 is greater than n2 or not. Fine. If it is true, if n1 is found greater than n2, then again I have to check like this, whether n1 is greater than n3 also. then only I can declare N1 to be the largest. So it forces me to check in 2 steps. Okay. Now there is another option that N1 becomes greater than N2. Fine. But N1 is not greater than N3. Then which will be larger? N3. So see, the combination of these 2 condition check, this is true, true, one outcome. This is true, false, another outcome. So in order to represent these 2 possible outcome, I am nesting one if else within this if block itself. Similarly, it is not complete yet. The same type of nesting is done inside the top level else also. Because when I found N1 is not greater than N2, that means N2 was greater than N1. Then what I am doing? I am again checking whether N2 is greater than N3. Then I can safely declare N2 to be the largest. Otherwise, N3 to be the largest. So you can see by enclosing one if else inside another if else, or in formal term nesting one if else block inside another if else block, I am doing my job very easily. Understood? Understood how our intuitive strategy can be implemented using nested if else block through C programming?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
So this is how, I mean, in this is very simple one, and you may find that there multiple level, more level, I mean, nesting another if else block within this if. It can go on. It can go on deep and deep. Okay. It is not only just enclosing one if else block within one if else block is permitted. You can have more than one nesting also. So multi-layer nesting is allowed. Okay. But when you are nesting, you should very careful about this dangling else problem. That a matching else must be available. You should keep it. That's what when you write such program using nested if else, you should properly indent different blocks so that you can easily check whether you have missed any else, matching else for a particular if block or not. Because there will be several if else like that. So you should not miss any one of them. You should keep all of them in proper matched. Every else should be matched with the appropriate if. And that's why you should use proper indentation. Although it is not mandatory, but it is always recommended. So else clause always associated with the closest unmatched if braces are not used. Suppose inside any block, if you have only one statement, then you can omit the curly braces. But if you have more than one, you should use curly braces. But we'll always encourage you to use curly braces so that you can follow the matching properly. Okay. Now, there is another extension of if else, as when we have for a same condition, when we have more than 2, that is 3 mutually exclusive outcome. Okay. Or I mean a kind of multi-layer conditional check when we have only 3 outcome, mutually exclusive outcome. That is called if else. Like if this condition is true, then do this. Else if this condition is true, then this. And by default, if neither of them matches, then do this. If this type of things need to be implemented, then we have to use if, this else if keyword. Remember, this is also a keyword. Else space if together, and then else. Let us show an example. This is we call if else if ladder, because this is a natural extension of that if else. If else if else. When we have multi-layer such conditional check and we have several mutually exclusive outcomes. Okay, I am going to show you one real life example how this if else if ladder should be used. Okay, this is another variant of if else. You should remember the nesting if else is a different thing, and this if else if ladder is a different thing, and they do have different situation of application that you need to understand. Okay, so this is the typical structure of an if else if ladder. If the expression will be there, then else if there will be another expression 2, under that there will be some block, then else if another text expression, there will be some block like that, and finally there will be a default case when none of these n-1 condition gets satisfied, all of them becomes false, then the final set of statement will get executed. Okay, let us see this example. This example actually illustrates that an example program that is going to print your grade based on your marks obtained. Like, you know, you used to get letter grade EX, then A, then B, C, D, then P, and the F. So if you get anything greater than 90, X, anything greater than 80, A, greater than equal to 70, B, greater than equal to 60, greater than equal to 50, greater than equal to 35, and less than 35. This is our grade assignment for a subject. So I am asking you to write a program that takes marks obtained and compute the grade. So let us see how I have written that program using this if else ladder. Just look at this. I have again taken the marks obtained by scanning F. Then if marks obtained greater than equal to 90, grade equal to X. See, I am using, instead of EX, I am using AX here. So such that I can declare, I have declared a character, single character, because if I use EX, it will be double character, so it will be considered as string. So that need to be handled differently, which we do not know yet. We'll learn that. But just I have changed this as X. Then else if marks obtained greater than equal to 80, then grade equal to A. Else if marks obtained greater than equal to 70, grade is B. So I am just implementing the same table like this. And this is my program. You just go through the program, you will quite easily understand that how this grade assignment is following the tabular thing and implementing the required thing.
Sir, we should use printf.
I have used. I have first see here. I have just taking the actual grade inside this grade variable, and finally outside of this entire block, I am printing the grade here. Instead of issuing printf statement everywhere, what I am doing, I have kept one extra variable which is being assigned based on the C. Only one, all of them are mutually exclusive outcome. See, at one run, the grade will either be assigned X or A or B or C or D or P or F. And this printf statement is going to be printed every time. without depending on this condition. So it will get some value, na? So that will be printed. So instead of writing this printf statement everywhere, I can write like this, no problem. Understood?
Yes, sir.
So this example program is just to illustrate how we can encounter different situations, different types of situation of branching, and how the different options provided by C helps us to implement that thing very easily. Understood? So there are different variants of conditional branching, using simple if, using simple if and else, using else if else, using else if ladder, or nested if else. So we have to actually, by practice, we have to understand the different situation while writing or solving a typical problem. We need to understand what situation we are getting, what should we apply. So you should follow these simple examples from that point of view. You should not just consider that this is the only example where we will be using if else or where we will be using else if. This is just a representative example, that this helps us to understand different scenarios of different types of conditional branching and how different options given by C can be used to implement them very easily. Understood?
Yes, sir.
So I am stopping here today, and I will conclude this remaining discussion, the
Sir,
other type of branching and also other type of, or along with a discussion to more detailed illustration, why, how we should think of using different types of options available, and what, in many cases, you can use several options, but how to choose the best possible or most efficient one, that I will illustrate in the next class. Okay. Is there any question from your side?
স্যার
বলো স্যাম।
আপনি যে স্যার প্রোগ্রামটা লিখলেন স্যার, ওতে যদি আমি 110 বসাই তাহলেও তো স্যার আমাকে এক্স দেখাবে। স্যার আমি কি এরকম রেস্ট্রিক্ট করতে পারি না?
হ্যাঁ, সেটা পারো। See, I have not, this type of thing, I am assuming, in order to make it simple, I am assuming that user knows that he or she has to enter less than 100, less than equal to 100 out of 100. Yeah. Now this error handling thing, obviously in practical programming you need to consider this thing, but here my intention was not to solve this particular problem properly. My intention was to show that how we should use this available if else if ladder in solving the core problem. Okay. So obviously your point is correct, but my intention was not to solve this particular problem. When I am asked to solve this particular problem only, then I will be also using, I'll be writing some code to catch or prevent any such error. Like someone enters negative number, then what would happen?